Dear students, today I am going to discuss the topics of flow through pipes. It is the part of fluid mechanics and machinery under Mechanical Engineering Department. At first, I am going to discuss what is the pipe flow, that is flow through pipes. Pipe flow is a branch of hydraulics and fluid mechanics, is a type of liquid flow within a closed conduit. Conduit is nothing, is a containment. Pipe flow does not have a free surface which is found in open channel flow. Pipe flow being confined within closed conduit, that is পাইপ ফ্লো সবসময় হবে একটা ক্লোজড কন্ডিট যার মধ্য দিয়ে কিন্তু ফ্লোটা হবে কন্টিনিউয়াসলি, দ্যাট ইজ does not exert direct atmospheric pressure but does not exert hydraulic pressure on the conduit. Now, in this chapter, the turbulent flow of fluids through pipes running full will be considered. That means আমরা কিন্তু এই পাইপ ফ্লোর মধ্যে দিয়ে যখন ফ্লুইডটা ফ্লো করবে আমরা ধরে নেব যেটা পুরো ক্রস সেকশনটা জুড়েই কিন্তু ফ্লো হবে। আদারওয়াইজ এটা আমরা কনসিডার করব কিভাবে, না এটা হচ্ছে না ওপেন সারফেস ফ্লো, অর তাহলে এটা আবার if the pipe are partially full, as in the case of sewer lines, the pressure inside the pipe is same and equal to atmospheric pressure. Then the fluid flow of the fluid in the pipe is not under pressure. This case will be taken in the flow of water through open channels, that is on the another topics or another chapter it may be considered as. So here we will consider flow of fluids through the pipes under only pressure. Now, laws of fluid friction. Actually, the characteristics of laminar and turbulent flow are very different. To understand why turbulent or laminar flow is desirable in the operation of a particular system, it is necessary to understand the characteristics of laminar and turbulent flow. Laminar flow, I have already discussed in previous chapter what is the laminar flow and the cross section and the flow, how the flow pattern arises in the laminar flow. I have already discussed, but it come to this particular in this chapter I have again says the different manners of the flow pattern in laminar flow. So layers of water flowing over the another at different speeds with virtually no mixing between layers. That means if we consider this is the flow pattern of the laminar flow, here all the particles proceed along smooth parallel paths and all the particles on any path will follow it without deviation. That means it cannot cross each other. Particular in this position, one particles can't mix the another particle, so there is no mixing in between layers. Fluid particles move in definite and observable paths or streamlines. The flow is characteristics of viscous fluid or is one in which viscosity of the fluid plays a significant part in the laminar flow. On the other hand, the turbulent flow, particular there is a mixing arises between the layers. It is the main keyword of this turbulent flow. Suppose this is the bathtub where we in the center position we take a cup, and from this above we pour this water from this mug. At what happened when we pour this water from this mug, there is a laminar flow considered, and particular after pouring the cup, then what happened, the fluid is mixing in different manners, particular in this picture. So here the average flow velocity is approximately equal to the velocity at the center of the pipe. So in other position, that is the that means in this particular figure, what happened, in particular figure there is a flow pattern is mixing between the different layers. So here is not an every here we can't differentiate in every each layer. So there is a mixing happens particular in turbulent flow. On the other hand, there is a transitional flow. In between this two flow, that is laminar flow and turbulent flow, it exists between laminar flow and turbulent flow. In this region, the flow is very unpredictable and often changeable back and forth between laminar and turbulent states. In this particular figure, we again elaborately shows this is the parallel lines of laminar flow, and particular in this below figure there is a turbulent flow, but in this figure the different each particle mix with each other or each other layer, particular in this figure. So there is a turbulency occur in turbulent flow. Now, loss of energy in pipes. There are two types of losses in this particular flow or flow through pipes. What happened in this particular happen? There are various types of losses in this flow, that is the flow through pipes. What happened actually, that is the two types of flow. One is that is the, if we say is another way, when fluid is flowing through a pipe, যখন ফ্লুইডটা পাস করে একটা পাইপের ভেতর দিয়ে, দ্য ফ্লুইড এক্সপিরিয়েন্সেস সাম রেজিস্ট্যান্সেস, ফ্লুইড কী করে না সাম একটা বাধা পায়, কারণ কি যে সারফেসের রাফনেস, মানে পাইপের ওয়ালের যে সারফেস আছে সেই সারফেসের রাফনেসের জন্য একটা রেজিস্ট্যান্স ফোর্স কাজ করে, ডিউ টু হুইচ সাম অফ এনার্জি ইজ লস্ট, তার জন্য কি হয় একটু কিছুটা পরিমাণ এনার্জি কিন্তু লস্ট হচ্ছে। দ্য লস অফ এনার্জি ইজ ক্লাসিফাইড অ্যাজ মেজর এনার্জি অফ লসেস অ্যান্ড মাইনর এনার্জি অফ লসেস. It actually what happened, but why it is the major energy losses? Friction, and it is calculated by the some two formulas, that is the Darcy-Weisbach formula and Chezy's formula. On the other hand, minor energy losses, this is due to the some of the features of the pipe, that is the sudden expansion of the pipe, sudden contraction of the pipe, bend in pipe fittings and obstruction in the pipe, etc. Now we discuss the major loss. Why major loss? When fluid is flowing through a pipe, the fluid experiences some resistance. We have already said this, due to some of energy is lost. The major loss is done due to the friction with the wall of pipes. The major loss are determined by Darcy-Weisbach formula, that is the HF, we decide that is the formula HF equals to 4FL V square upon 2GD, or we can write FL Q square upon 3D to the power 5, where HF equals to head loss due to the friction, or L equals to length of the pipe, P V equals to velocity of the flow, D equals to diameter of the pipe, and Q equals to discharge of the fluid. And particular small f, that is the frictional resistance or coefficient of friction, it may be written as 0.079 by Re to the power 1 by 4 or Rn to the power 1 by 4, that is the Reynolds number. Actually we বলে রাখা ভালো, রেনল্ডস নাম্বার অ্যাকচুয়ালি কী হয় না ইনার্সিয়া ফোর্স টু দ্য ভিসকাস ফোর্স। হোয়াট ইজ মানে অ্যাকচুয়ালি এটা হচ্ছে একটা রেশিও, রেনল্ডস নাম্বার ইট ইজ ডিফাইন্ড অ্যাজ দ্য রেশিও অফ ইনার্সিয়া ফোর্স টু দ্য ভিসকাস ফোর্স, দ্যাট মিন্স রো ভি ডি ওয়াই মিউ. Mu is the coefficient of dynamic viscosity or coefficient of viscosity, and rho is equals to the density of the fluid, V for velocity of the fluid, and D equals to small d, that is the diameter of the rho VD d. And on the another way we can write VD by nu, that is the kinematic viscosity. Kinematic viscosity means it is defined as the ratio of dynamic viscosity to the density. So mu upon rho equals to nu, we can write. Now second formula is Chezy's formula. Chezy's formula means that is also we can write VHF, that is the head loss due to friction, HF equals to 4FL V square upon 2GD. That is we already we can also write that 4FL C square MI upon 2GD. V equals to C root over MI V square, that means C square into MI. Now so where C equals to key, we can consider as the Chezy's constant. So here there is two terms M and I. M and I. So M is hydraulic mean depth, that is the A upon P. A means area of the flow and P equals to weighted perimeter of the pipe. And there is a new term, that is the I, loss of head per unit length of the pipe. I equals to HF, we can write also I equals to HF by L, where HF equals to head loss due to friction. So if we find out the head loss due to friction HF, that is equals to, we can write HF equals to I multiplied by L, that is the I into L. Now the minor loss. The minor loss, there is a, we have already said the minor loss is the various types of condition of the pipe. So at first loss of head due to the sudden enlargement, দেখা গেল কোনো পাইপ হঠাৎ করে সরু মানে একটা তার পার্টিকুলার ক্রস সেকশনটা হঠাৎ করে বেড়ে গেল, দ্যাট মিন্স হেয়ার ইজ দ্য এনলার্জমেন্ট অফ দ্য pipe. So here head loss due to sudden enlargement, সেই হঠাৎ করে বেড়ে যাওয়ার জন্য কি হলো, particular in this figure what happened in 1 cross section and 2 cross section from the V1 in this figure the arrow line shows the flow is traveling from particular 1 to 2 section, and 2 section what happened in enlargement of the pipe. So what happened, that is the HE equals to V1 square minus V2 square by 2Z, that is the condition of the head, that is the head loss due to the sudden enlargement. On the other hand, what happened, loss of head due to the sudden contraction. In the this is the figure is the opposite of the sudden enlargement. So what happened, that is the HC, C for contraction, HC, H head loss, that is the H, and C equals to sudden contraction HC equals to K into V2 square by 2G. That means V2 is the suddenly contraction, মানে হঠাৎ করে শুরু হয়ে গেছে, তো এর ক্ষেত্রে কি হবে যে K into V2 square by 2G. And now K equals to কি, K equals to the k equals to 1 is the k equals to 1 constant, that is equals to 1 by cc minus 1 এর whole square, that is the cc means coefficient of contraction, that is the area of 2 section upon area of 1 section. Normally cc is considered as the 0.375, that is the value of the cc. Now loss of head at inlet of pipe or entrance, দ্যাট ইজ দ্য ইনলেট, যদি কোনো মানে হঠাৎ করে একটা ইনলেট মানে এন্ট্রান্সে যদি ফ্লোটা জাস্ট একটা এন্ট্রান্সের মধ্যে দিয়ে যাচ্ছে, তো ইনলেটের মধ্যে দিয়ে যাচ্ছে বাট একটা জাস্ট শুরু করলো, তো সেই ক্ষেত্রে একটা হেড লস কিন্তু লস অফ হেড কিন্তু হয়, যার জন্য কি মানে দ্যাট ইজ দ্য HI or HE we can't write because HE as considered as the sudden enlargement. So here HI equals to 0.5 into V2 square by 2G. On the other next, loss of head at exit or outlet of the pipe, তার মানেটা কি, যখন fluid or water is পাসিং জাস্ট এক্সিট অফ দ্য জাস্ট বেরোচ্ছে কোনো পাইপের ভেতর থেকে, দেন অ্যাট দ্যাট টাইম দেয়ার ইজ এ লস. সো হোয়াট হ্যাপেন, HO ইকুয়ালস টু V স্কোয়ার বাই 2G, V স্কোয়ার বাই 2G. তো দ্যাট ইজ দ্য V ইকুয়ালস টু ভেলোসিটি অফ দ্য ফ্লুইড. সো নাও লস অফ হেড ডিউ টু অবস্ট্রাকশান, দ্যাট ইজ দ্য, দেখা গেল একটা পাইপের ভেতর দিয়ে জল যাচ্ছে, জল যেতে যেতে হঠাৎ বা ফ্লুইড, যে কোনো ফ্লুইড যাচ্ছে, হঠাৎ কী করলো, একটা অবস্ট্রাকশান পেলো, তো পার্টিকুলার at that situation what happen, OB for obstruction. So what happen, A upon CC, that is the coefficient of contraction into capital A minus A. Capital A is the pipe cross sectional area of the pipe, particular in this figure in on the right side, and minus A, that is the small a is the area of the obstacle or obstruction, minus 1 এর স্কোয়ার 1 এর হোল স্কোয়ার ইন্টু V স্কোয়ার আপন 2G, that is where what happen, and CC is the coefficient of contraction, that is already I have discussed, that is the area of the 2 section or here area of the obstacle or obstruction by upon by area of the cross section of the pipe. Next topic, loss of head due to bend in pipe. সাপোজ যদি একটা পাইপের মধ্যে হঠাৎ বেন্ড পড়ে, মানে কোনো জায়গায় that may be 30 degree or 45 degree or 90 degree. So particular at that section what happen, HB, that is the K into V square by 2G, where K is the coefficient of bend, that is the depending on angle of bend. সাপোজ আমি একটু আগেই বলেছি সেটা, ডিপেন্ডিং অন অ্যাঙ্গেল অফ দ্য বেন্ড, ইট মে বি 30 ডিগ্রি 15 ডিগ্রি 90 ডিগ্রি, such type of radius of curvature of bend and diameter of the pipe. And last of all, loss of head due to the various pipe fittings. কোনো জায়গায় পাইপ ফিটিংস করতে হয় এবং কোনো জায়গায় যদি আমরা ভাল্ব দিয়ে থাকি, সে সমস্ত ক্ষেত্রে প্রত্যেকটা সেকশানের ক্ষেত্রে কিন্তু আলাদা আলাদা এই আমরা হেড লস আমরা পাবো. সো এক্ষেত্রে head loss due to the pipe fittings, that is the HP equals to K into V square upon 2G, where K equals to coefficient of pipe fittings. Okay, thank you. Waiting for my next video for part 2, fluid flow through pipes. Thank you.